There's a Benchy sitting on a shelf in a basement workshop right now that cost 11 cents to print. The machine that made it cost $269. The layer lines are invisible to the naked eye, the hull is smooth, the cabin roof bridged without a single strand of filament sagging into the void below. And the person who printed it has never heard of that printer's name mentioned in a single sponsored video on YouTube. That Benchy is not famous, but it is flawless, and the machine that made it belongs to a category that the 3D printing industry does not want you to discover. Because every unit sold at that price point is a receipt that proves the $1,000 machines above it are charging for marketing, not engineering. The 3D printing market operates on a principle that most consumers never examine. The principle is this: visibility equals value. The brands that appear in the most thumbnails, the most affiliate roundups, the most sponsored first look reviews are the brands that consumers trust. But visibility is purchased. It is a budget line item. And every dollar a company spends on a YouTube sponsorship is a dollar that did not go into the bill of materials of the machine sitting in your cart. The 5 printers in this investigation were selected using a different metric entirely. Not visibility, not hype, not subscriber counts. The metric was silence. These are the machines that appear most frequently in Reddit threads titled, "What printer do you actually use every day?" In Discord channels where engineers share their work tables and makerspaces where the equipment has to survive being used by strangers 8 hours a day. These are the printers that people stopped talking about because they stopped having problems worth mentioning. And that silence is the most honest review a machine can receive. The first goldmine is the Elegoo Centauri Carbon. And the reason it belongs at the top of this list is not its spec sheet, although that spec sheet is absurd for the price. It is a single engineering decision that Elegoo made during development that reveals everything about the company's priorities. They used a die-cast aluminum frame, not stamped sheet metal, not folded aluminum extrusion bolted together at the corners. Die-cast. That is a manufacturing process, typically reserved for machines costing $600 or more. The die-cast frame eliminates flex. It eliminates resonance. It eliminates the micro vibrations that create ghosting artifacts on the surface of prints, those faint ripples around sharp corners that most budget printers produce, and most reviewers politely ignore. At $299, the Centauri Carbon is a fully enclosed Core XY printer with 500 millimeters per second maximum speed, a hardened steel nozzle rated to 320 degrees Celsius, a dual-sided PEI build plate, automatic calibration, input shaping, and a built-in camera. It prints PLA, PETG, ABS, ASA, TPU, and carbon fiber composites. After hundreds of hours of use documented across independent reviewers, the failure rate is functionally zero. No clogged nozzles, no mechanical breakdowns, no belt tension drift. The Bambu P1S offers a nearly identical feature set in an enclosed Core XY format. It costs $699. The Centauri Carbon costs less than half. And in side-by-side surface quality comparisons, the prints are indistinguishable. That is not a slight against Bambu Lab. That is a testament to what Elegoo accomplished by spending money on frame rigidity instead of marketing contracts. The Centauri Carbon does not have a mobile app. The interior light on earlier units was dim enough to be useless. The proprietary firmware limits tinkering for the Clipper crowd. These are real limitations. They're also irrelevant to the 90% of users who care about one thing: does the print come out clean? The answer, consistently, is yes. The second goldmine is the Sovol SV06 Ace. And this printer exists for a very specific person, the person who wants to understand their machine, not just operate it. The SV06 Ace ships with vanilla Clipper firmware. Not a proprietary fork, not a locked-down derivative. Stock Clipper running on a 64-bit processor with full mainsail web interface access out of the box. That means every setting, every calibration parameter, every pressure advance value, every input shaping frequency is visible, adjustable, and documented by the largest open-source 3D printing community on the planet. At $269, you're buying a machine that runs the same firmware architecture as custom-built Voron printers costing $800 or more. The hardware earns the software. The SV06 Ace uses linear rods instead of the Palm V-wheels that most budget printers rely on. V-wheels wear. They develop flat spots after a few hundred hours. They introduce wobble that shows up as inconsistent layer lines on tall prints. Linear rods do not degrade at the same rate. They maintain dimensional accuracy for thousands of hours. The direct drive extruder uses a planetary gear system with a 7.5:1 ratio, which means it handles flexible filaments like TPU without the jamming and buckling that Bowden tube printers produce. The all-metal Hotan reaches 300 degrees, opening the door to nylon and polycarbonate blends without requiring aftermarket upgrades. Sovol also included something unexpected at this price: a built-in camera with remote monitoring through the mainsail interface. It is not a high-resolution camera. It will not produce cinematic time lapses. But it will show you whether your 14-hour overnight print is still attached to the bed at 3 in the morning, and that alone justifies its inclusion. The SV06 Ace is loud. The cooling fan is audibly whiny at high speeds. The touchscreen ribbon cable has a documented fragility issue in early production runs that Sovel has since addressed. Customer support is functional but not exceptional. These are the trade-offs of a machine built to a price. But the core proposition remains. For under $300, there's no other printer on the market that gives you full, unrestricted Clipper access on hardware that can actually use it. The third goldmine is the Anycubic Cobra 3 combo, and this printer earns its place on this list for one reason that overshadows everything else about it. It is the cheapest way to get reliable multicolor printing in 2026. Multicolor printing used to be a luxury. The Bambu Lab A1 with AMS Lite costs over $400. The Prusa MMU3 system requires a $700 base printer, plus a $200 add-on. The Cobra 3 combo ships as a complete package, printer plus Ace Pro multicolor unit, for under $350 during frequent promotional pricing. The SE Pro system handles 4 filaments simultaneously with a purge tower that is smaller than the Bambu AMS equivalent, which means less wasted filament per color change. The mechanical reliability of the color switching system has improved dramatically from earlier Anycubic multicolor attempts. Jams are infrequent. Color transitions are clean. The registration accuracy between colors is tight enough for display models, cosplay components, and multi-part mechanical assemblies. The print speed reaches 300 millimeters per second on the standard profile, which is not the fastest in this price range, but is fast enough that a multicolor Benchy completes in under 40 minutes. The bed leveling is automatic and uses a strain gauge system that is more consistent than inductive probes on textured surfaces. The slicer is a fork of Cura with built-in multicolor project support. Is it perfect? No. The build volume is modest at 220 millimeters cubed. The enclosure is open, which limits ABS and ASA performance. The touchscreen interface is functional but not intuitive. But none of those limitations change the fundamental calculation. If you want 4-color printing for under $350, no other machine in 2026 can match this value proposition. Not one. The fourth goldmine is a printer that almost nobody outside of the engineering and cosplay communities talks about. The Sovel SV06 Plus Ace. And the reason nobody talks about it is the same reason it belongs on this list. It is a large format printer that is priced like a standard format machine. The build volume is 300 by 300 by 350 millimeters. That is large enough to print a full-size cosplay helmet in a single piece, a complete leg armor section without splitting it into 4 parts and gluing them together, a functional drone frame, a structural bracket for furniture. Most printers with this build volume cost between $500 and $900. The SV06 Plus Ace retails for $349 and frequently goes on sale for $299. Like its smaller sibling, it runs vanilla Clipper. The hood end reaches 300 degrees. The extruder is planetary direct drive. The bed uses dual Z-axis motors for stability across that large print surface. The auto-leveling system uses adaptive probing, which means it only maps the area of the bed where the actual print will sit, reducing calibration time on smaller prints. Tom's Hardware gave it an Editor's Choice Award and called it one of the best recommendations for cosplayers. That endorsement was not purchased. It was earned by a machine that prints big, prints fast, and costs less than a set of tires. The trade-offs are the same as the smaller SV06 Ace. Fan noise, support that is adequate but not exceptional, and a learning curve for users who have never interacted with Clipper's web interface. But for the user who needs volume, literal physical volume, and refuses to pay the premium that most brands charge for larger build plates, the SV06 Plus Ace is the most rational purchase in the market. There's a decision that every person who owns a 3D printer has to make eventually. Not which brand, not which model. The decision is whether they are willing to spend 30 minutes learning how their machine works, or whether they want to pay $300 extra for someone else to make that unnecessary. Both choices are valid, but only one of them is transparent about the cost. The 5 printers on this list are not the easiest machines to unbox and operate. They are not the most marketed. They are not the ones with the prettiest slicer interfaces or the smoothest onboarding tutorials. But they are the machines that deliver the highest ratio of print quality to dollars spent, confirmed by thousands of users who have no affiliate links, no sponsorship deals, and no reason to lie. There is a guide pinned in the comments below this video. It contains the exact model numbers, the current best prices across platforms, and a checklist of questions to ask yourself before purchasing any printer at any price point. Use it. The 5th goldmine breaks every rule on this list because it is not a printer that anyone would call cheap in the traditional sense. It is the Elegoo Centauri Carbon 2 combo, and it costs $449. That is more than every other machine discussed today. And it is on this list because what it delivers at that price did not exist at any price 18 months ago. The Centauri Carbon 2 combo is a fully enclosed Core XY printer with 4-color multi-material printing, a hardened steel nozzle rated to 350 degrees Celsius, automatic calibration, input shaping, and a build volume of 256 millimeters cubed. The canvas color system handles filament switching with mechanical reliability that matches or exceeds the Bambu Lab AMS at nearly half the system cost. It prints PLA, PETG, ABS, ASA, TPU, nylon, and carbon fiber composites without nozzle swaps or aftermarket modifications. During 3 weeks of independent testing, the printer handled multicolor jobs, engineering grade materials, and overnight unsupervised runs without a single failure that required intervention. The print quality on multicolor objects is clean enough that no post-processing is needed for display quality results. The closest competitor offering comparable specifications is the Bambu Lab P1S with AMS, which costs over $800. The Prusa MK4S with MMU3 exceeds $1,000. The Centauri Carbon 2 combo delivers 90% of the capability of both machines at roughly half the price. It is not cloud dependent, it does not require an account to print, it does not lock firmware, it does not send cease and desist letters to developers. It simply prints in 4 colors at speeds that would have been flagship performance 2 years ago, for a price that makes the entire premium segment of the market look like it has been overcharging for features that are no longer expensive to manufacture. The Benchy on the shelf has not moved. It is still sitting there, 11 cents worth of PLA shaped into a form that has become the universal language of 3D printing quality. But the machine that printed it is no longer a secret. It is a data point. And when enough data points accumulate, when enough people discover that the machines they never heard of outperform the machines they saw in every ad, the pricing structure of the entire industry will have to answer for the gap between what these printers cost and what the famous ones charge. That gap is not innovation. It is not research and development. It is not superior engineering. It is marketing. And marketing, unlike a die-cast aluminum frame, does not make your prints any better. It does not reduce your layer height. It does not eliminate your stringing. It does not keep your 14-hour print attached to the bed at 3 in the morning. Only the hardware does that. And the hardware on this list costs less than a month of streaming subscriptions.